Assalamualaikum warahmatullahi wabarakatuh and hello to everyone. So our topic today is aluminium in aircraft, how it used. So first of all, what is history of aluminium in the aerospace industry? Aluminium has a long and illustrious history in the aerospace industry. Aluminium was really utilized in aviation before aeroplanes were even invented. The frames of Count Ferdinand Zeppelin's Zeppelin airships were made of aluminium in the late 19th century. So next is we want to talk about the Wright brothers Wright Flyer. The plane was constructed from a Sitka spruce and bamboo frame covered in canvas because aluminium was not widely accessible and prohibitively expensive. Because of the plane's low air speeds and limited lift generating capability, making the frame as light as possible was critical, and wood was the only material that was both light enough to fly and strong enough to hold the requisite load. Next is aircraft in World War I. Wooden planks were popular in the early days of aviation, but after World War I, lightweight aluminium began to supplant wood as the primary component in aeronautical production. Next, we want to talk about the Junkers J1 monoplane. Hugo Junkers created the world's first complete metal aircraft. Its fuselage was built of copper, magnesium, and manganese based on aluminium alloy. So, during the World War II, aluminium was needed for numerous military applications, particularly the construction of aircraft frames, which caused aluminium production to soar. Because of the high demand for aluminium, WOR NYC broadcasted a radio show called Aluminium for Defense in 1942 to encourage Americans to donate scrap aluminium to war effort. To tinfoil drive, give free music tickets in exchange for aluminium foil balls, and metal recycling was encouraged. Between July 1940 and August 1945, the United States built an astonishing 290,000 aeroplanes. Moreover, half were mostly constructed of aluminium. The aircraft industry in the United States was able to meet the needs of the American military as well as American allies such as the United Kingdom. In 1944, American aircraft planes were manufacturing 11 planes per hour at their peak. So next, we want to know why aluminium is so important in airplanes and what is the properties and benefits of aluminium. Thank you.
After knowing about the aluminium history in aircraft and aerospace industry, you should know about the aluminium properties and its benefits that change the world. Okay, so compared to steel, aluminium is much more lighter because it is low density, which make it as a perfect match to be in an aviation industry. However, aluminium itself is just not strong enough. So back then, people was trying to look for ways to make aluminium much more harder and stronger. This can be done by making aluminium alloy. Aluminium alloy consists of copper, manganese, and magnesium. This aluminium alloy, we call it as duralumin. And did you know that duralumin grows harder as it ages? Yes, duralumin have the properties of age hardening that's related to the duralumin atomic structure, which help it reinforce. Let's take a look at the metal crystalline structure first. A group of metal atoms join and form a regular pattern with a repeated structure. Aluminium's atom forms a repeating crystalline structure called as face-centered cubic, which gives the aluminium atoms to slip over easily and make a new shape. But when copper, manganese and magnesium is added to the aluminium, it destroys the regular patterns of the atoms. This is because the atoms of these elements are different in shape compared to aluminium itself. Therefore, it creates an internal strain that makes it harder and much more stronger. Even though this process makes it stronger and harder, duralumin is still in a low density, which is the reason why people choose aluminium to make aircraft, so it can fly easily. Other than that, aluminium also resistant to corrosion. Despite of having a high reactivity, aluminium also reacts with oxygen to produce a protective oxide layer called aluminium oxide. The protective layer of aluminium oxide are tightly packed, strong, non-porous, and difficult to peel off. So, this protective layer is very resistant to corrosion that it won't react with anything else. But I wonder, what are the characteristics and the application of aluminium in aircraft? Let's ask Aisha for some explanation.
So you guys must be wondering what are the characteristics and the application for the aluminiums that are best suited for the aircraft. So today I will be explaining to you guys about the two main aircraft grades, which are Aluminium 2024 and Aluminium 7075. Before that, I need to explain to you guys about some of the characteristics. Formability refers to the ease which a material can be formed while satisfying quality requirements. Machinability is the ease which a metal can be cut, permitting the removal of the material with a satisfactory finish at low cost. And corrosion resistance is the ability to prevent environmental deterioration by chemical or electrochemical reaction. Weldability is the ability of any material, usually metals and its alloys, to weld with similar materials. Aluminium 2024 has a high strength-to-weight ratio, which makes it extremely fatigue resistant. It is often used in the building of an aircraft's wings and fuselage. The most frequent temper designation for this aluminium grade are 2024 T3, 2024 T4 or T51, and 2024 T851. The characteristics of aluminium 2024 is heat-treated, good formability or workability, high strength, fair machinability, poor corrosion resistance, and poor weldability. Aluminium 2024 is often used for the following applications since it is one of the best high-strength aluminium and has great fatigue resistance, which is structural components of aircraft such as wings and fuselage, aircraft fittings, truck wheels, hardware, parts that are required by the transportation industry, scientific instruments, and veterinary equipment. Next will be the Aluminium 7075. 7075 aluminium is another kind of aluminium that is extensively utilized in aircraft construction. Aluminium 7075 is one of the strongest aluminium alloys available, on par with several types of steel. Because of its high strength threshold, it is frequently utilized for elements of the aircraft that are subjected to extreme stress, such as the wing spar. The characteristic of aluminium 7075 is heat-treated, high strength, average resistance to corrosion, fair machinability, poor formability or workability, and poor weldability. Aluminium 7075 is often used for the following applications due to its high strength and resistance to stress corrosion cracking, which is structural parts that are highly stressed, fittings for aircraft, shafts and gears, components of missiles, additional parts for the aircraft and aerospace industry.
She's a Mona Lisa. Everyone's lining up to see her. There must be something